This way, enter the values.
Trial version.
Mod of xi minus x bar. X bar is 125.3.
Trial version.
This will be 25.3.
Yes, sir.
Multiplied by the frequency
227.7.
287.
227.7.
This way you have to complete the table. I'm not writing all the values.
Trial version.
Find out. It will be answer.
Trial version.
Table will be like this.
Trial version.
So, Bodhija, just tell me the
Trial
values. Fi, sigma Fi xi minus x bar. This value, total.
Yes. So 11288.
Trial version.
And
that is
this
100.
was 100.
Sorry, sir. That is fixy
version.
minus x bar. That is 1128.8. There is a decimal point between. Yes. Sir.
Trial version.
So, mean deviation about the mean.
Trial version. Trial version.
All of you, please check this value because I haven't calculated this
Trial
both these
version.
values. If you are getting the same value,
Trial version.
11.28.
Trial version.
Number 6. Just 1 minute.
Trial version. Trial version.
Okay.
Trial version. Trial version.
Now we'll move on to standard deviation and variance.
Trial version.
So I hope you can complete this.
Trial version. Trial version. Trial version.
What is your second line? Mod of xi minus. Oh, this was
Trial version.
15.3. Fi into mod xi minus x bar. Second line.
Trial version.
So 198.9.
198.9. That is 15.3
Trial
into
version.
13.
Yes, sir.
Trial version.
This way complete the table.
Trial
Is it
version.
okay? Is there any doubt in this? It's so simple. standard deviation is somewhat similar. In standard
Trial
deviation,
version.
we again find out the deviation from the mean. But instead of finding the absolute value of the deviation, what we do, if we
Trial
square
version.
it, that is xi minus x bar whole square, square it, just to make all the deviations positive. Instead of taking the absolute value,
Trial
we
version.
square them. After squaring these deviations from the mean, we multiply them with the corresponding frequencies. Then we add them up.
Trial version.
And at the end, divide by sigma fi, total frequency, and take the square root. Take the square root because initially we squared all the
version.
deviations. So then what do I mean? Standard deviation. What is it? Let's have a look.
Trial version.
So if if there is no frequency at all for a simple set of numbers, x1, x2, x3, up to xn, what do? We first find out
Trial
the mean,
version.
just like the previous one, we find out the mean. Then you find out the deviations. Take each number, x1, then x1 minus x bar. Next, take the
Trial
next
version.
number, x2. Again, find x2 minus x bar. This way, find out the deviations of each number from the mean. After finding the deviation,
Trial
square
version.
it. So we get the squares of the deviations from the mean. Then you add up all these square deviations. After adding the
version.
square deviations, we divide by n. So we get the average of the squared deviations. Then you take the root,
Trial
square root.
version.
So actually you get the root of the mean of the squares of the deviations from the mean.
Trial
Root
version.
of the mean of the squares of the deviations from the mean, we may call it RMS deviations from the mean. RMS, root of mean of square of deviations from the mean.
Trial
So you may
version.
remember it as RMS deviations. If we simplify this formula, that is if we expand xi minus x bar whole square, which is equal to xi square
Trial version.
minus 2 x bar into xi plus x bar square, and then you apply the summation sigma on these three terms and simplify it.
Trial version.
We get sigma xi square by n minus x bar whole square. So the same formula can also be put into this form.
Trial version.
Now the question arises, which formula do we use? Which one? Practically speaking, the second formula is easier to use.
Trial
Because in
version.
the first one, first you have to find out the mean, then find out the deviations of the each number from the mean, then square it,
Trial version.
and then find out, then divide by n. Tedious job. First of all, if the mean is a whole number, it is fine. If the mean itself is a fraction,
Trial
a
version.
decimal fraction, then you have to find out the deviation of each number from this fractional value. So quite likely that the deviations will be
Trial
also
version.
fractions. Then you square them. You can imagine the squares of the fractions up to certain decimal points will be a tedious job.
Trial version.
And then divide by n after finding the sum. So if x bar is a whole number, it is fine. If it is not advisable to
Trial
use the
version.
first formula. Instead, use the equivalent second formula. This is absolutely all right, perfect. It is the same formula
Trial version.
in a different form, but here we don't have to find out the mean separately. We just make a column for x square. X will be given to us. The
Trial
values of x
version.
will be given to us. We just make a column for x square. Then you find out sigma x and find out sigma x square. Okay, and divide
Trial
by n
version.
and use it, put the values in the formula. And you get the answer. If the same thing is given with frequency
Trial
distribution,
version.
but before that, there's something called variance. Variance is the square of the standard deviation. If the standard deviation is sigma, then the variance is sigma
Trial
square.
version.
Because it is about the variable x, so we call it sigma x, sigma suffix x. If it is for the variable y, it will be sigma y, like that. The symbol is sigma.
Trial version.
X denotes the variate that is used, sigma x. So when we square it, that is the square root is removed. Sigma square is the
Trial
variance. So basically variance is the square of the standard deviation. All right. If the data is given
Trial
as a
version.
discrete distribution with frequencies, that is, if the values of the variate x1, x2, x3 up to xn, they come with corresponding frequencies
Trial version.
f1, f2, f3 up to fn. In that case, the formula will be weighted formula. That is, it is fine. You find out the
Trial
mean
version.
xi and find out the deviations xi minus x bar, square it, xi minus x bar whole square, multiply each square deviation by the corresponding
version.
frequency, so you get fi into xi minus x bar whole square. Find the sum, divide this sum by total frequency sigma
Trial
fi,
version.
and at the end take a square root. Again, the same formula can be put in a more simplified form. You don't have to find out the
Trial
mean
version.
separately. Instead, values of x given, frequencies given, we make two columns. One column
Trial
fi
version.
into xi, and the other column is fi into xi square. Fi into xi square, only xi square, that is
Trial
square
version.
the value of x and then multiply with fi into xi square. Find the sum and put into the formula. This is easier. You don't have
Trial
to find the
version.
mean. For a group distribution, the same formula will be used. But for the group distribution, the values of x will be the mid values of each interval. So we use these formulas one by one for each type.
Trial version.
First of all, we take a series of numbers. Say, for example,
Trial version.
here I'll give you this sum for classwork. I'll give you a separate sum.
Trial version.
Take
Trial version. 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 Trial version.
Sir, variance will be just the square of standard deviation.
Trial version.
this is the sum.
Trial version.
So let us make a table for this.
Trial version.
We also do it directly without constructing any table like that. But the table looks nice.
Trial
So
version.
one column for x, another column for x square.
Trial version.
1, 2, 3, 4, 5, 6, 7, 8.
Trial version. 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 Trial version.
The variance is 70/3 and standard deviation is root 70/3.
This is
Trial
question
version.
number 3. 14.5. I'll just check it.
Trial version.
Both correct. 70/3 and root over
Trial
70/3.
Yes, sir.
Then just call out the values.
Trial version. Trial version. Trial version. Trial version.
Total sigma xi square.
Trial version. Trial
Sigma
version.
xi first.
Trial version.
So 434 sigma xi square. Sigma xi square.
Trial version.
434.
Trial version. Trial version.
Did you say 434?
Trial version.
Yes, sir.
So
Trial version.
n is 6.
So this question I calculated directly. I mean, using xi minus, it became easier. I mean,
Trial
using the
version.
first formula.
Finding the mean.
Yes, sir,
Okay.
directly. I mean, using that.
Okay,
way.
okay.
Trial version.
First question was to find the variance.
Trial version.
copy the formula.
Trial version. Trial version. Trial version. Trial version.
Or 34 by 6 minus
Trial version.
42 by 6 whole square. That is 7 square.
Trial version. Trial version. Trial version.
And this is, you said, 70 by 3.
Yes, sir.
Okay.
Trial version. Trial version. Trial version. Trial version. Trial version.
Then we'll take one with class intervals,
version.
group distribution.
Trial version. Trial version. Trial version. Trial version.
Let's take this one, number 10.
Trial version. Trial version.
Can you read now? The only difference is
Trial version.
the values of xi will come from the mid values of these intervals. So the values of xi are 35, 45, 55, 65, and so on.
Trial version.
Now, the values will be large. If you take the values of the, if you take the mid values, 35, 45, 55, 65, with the corresponding
Trial
frequencies,
version.
and particularly when you find fi into xi square, we'll square the number. Say, for example, 65 squared into 15.
Trial version.
Okay, that will be quite large. There's a shortcut method. There's a shortcut method and also a step division
Trial
method, just
version.
like the methods you used in class 10 for the calculation of means, in which the step division method is the shortest.
Trial version.
So similarly, in calculation of standard deviation also, there's a step division method.
Trial version. Trial version.
Which columns do we make? Let us solve now.
Trial version.
class interval, then frequency, mid value,
Trial version.
psi. We use a new variable u. Let us go for the step division method. So u
Trial
fi
version.
ui square. So 6 and
Trial version.
1, 2, 3, 4, 5, 6, 7, 8, 9. 6 by 9.
Trial version. Trial version. Trial version. Trial version.
Copy the table and start doing it.
Trial version. Trial version. Trial version. Trial version. Trial version. Trial version.
So do we have to find the mean also using step deviation, or we can find the mean using this?
No, leave the mean. Only variance.
Trial
Only
version.
variance and standard deviation.
Trial version. Trial version.
Value u.
Trial version.
U will tell me value of u.
Trial version. 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 Trial
Now you tell
version.
me what should be ui? Xi minus, which is the middlemost value of xi? 1, 2, 3, 4, 5, 6, 7.
65.
Trial version.
65.
65, sir.
Yes, so xi minus
By 10.
65 by the class size. Class size 10.
10.
It's C
Trial
actually. It
version.
is C, yes, 10. So, what are the values? From the experience of class 10, tell me, what should it be?
This one
Trial
minus 3.
version.
The minus
Yes.
3,
Minus 3.
minus 2,
Minus 2, minus 1, 0, 1, 2, 3.
and then minus 1, 0, 1, 2, 3.
Yes.
Trial version.
It's similar to mean calculation.
Mm-hmm. Oh, sure.
Trial version.
Octo.
Trial version. Trial version. Trial version. Trial version.
So is the sixth column fi ui whole square?
No.
Fi ui square.
Yes.
Okay. Sir.
Trial version.
FIUI.
Trial version.
Seven into minus 2. 12
Trial
into
version.
minus 1. 0. 8 into 1. And
Trial version.
check column.
6
6.
and 6.
6 again.
24.
Trial
First
version.
square ui, that is ui squared is 9. Minus 3 whole squared is 9. 9 into 3, 27. Like this. First
28.
square the value of u. Minus 2.
Trial
Value
version.
of ui is minus 2. Square it. 4. Into 7, 28. Like this. Better this is
Trial version.
12. 0.
0,
8.
8, and
12.
12.
18.
Trial version.
Total. I need the total of sigma fi ui, sigma fi ui square, and sigma fi.
Trial version.
These three. First of all, sigma fi.
50.
Next is sigma
Trial
fi ui.
version.
Don't make a mistake.
Minus 15.
Minus 1 5. Fi ui square.
Trial version.
105.
Please check all of you.
Trial version.
Check the entries. Check the totals. Then mean is equal. Sorry. First one is variance.
Trial
Variance is
version.
equal to first write the formula.
Trial version.
Here the formula is the step division formula.
Trial version.
That is this.
Trial version.
Oh, you're finding this variance.
Trial version. Trial version.
For the variance,
version.
this whole into just a minute. Whole into
Trial version.
c square.
Trial version.
C is 10 here. Okay. Now substitute.
Trial version. Trial version.
Sigma fi ey square 105 divided by
Trial
sigma
version.
fi 50 minus sigma fi ey minus 15 by 50 whole square.
Trial
So
version.
the square of
Trial version.
minus 15 by 50 whole square multiplied by
Trial version.
10 square. Compute
Trial
this.
version.
Use the calculator. Compute.
Trial version. Trial version. Trial version. Trial version. Trial version. Trial version. Trial version.
Set 201.
201.
Trial version.
So I'm checking one second.
Trial version. Trial version.
Correct. 201.
Yes, 201.
Trial version.
And standard deviation.
Trial version.
Is equal to square root of the variance,
Trial version.
which is
14.18.
Trial version. Trial version. Trial version. Trial version.
approximately. Correct to 2 decimal places. 14.18 correct to 2
Trial
decimal
version.
places. There is
Trial
something more.
version.
So if we
Yes.
Trial version.
which method we use, derivation of the formula.
Please come again. I couldn't hear you. Voice is cracking.
So,
Trial version.
which method should we use? Derivation one or number one?
Who is speaking? Boydud
Trial
or
version.
Astran? Your voice is cracking. Or whose net is weak? Is it mine? Can you hear me clearly?
Trial version.
I can hear you, sir.
So this must be Boydud's net.
So can you hear me?
Yes, now it's okay.
Trial
Yes, sir.
version.
Your voice is very clear.
Okay.
So I was studying that if in the question they have not mentioned which method to use, so which method will we use? I mean,
The most
derivation-
convenient, the most convenient
version.
method. If nothing is mentioned, I'll go for the shortest, the easiest, the most convenient method, and that is the step division method. Provided all the class intervals are uniform,
Trial version.
the class sizes are uniform. If the class sizes are uniform, I'll definitely go for the step division method. It is the easiest.
Okay, sir.
Trial version.
The only other thing that we need to know is
Trial
there's
version.
something called, there's a statistical tool that is called the coefficient of variation. I'll show you the formula.
Trial version.
So I discussed all these formulas with you. Variance, shortcut method. Shortcut
Trial
method
version.
is just like shortcut method in calculation of mean, class 10, the same thing. You don't divide by something.
Trial version.
You don't divide. Just subtract the assumed mean from each value. Just use di equal to xi minus a. In that case, in the formula for standard
Trial
deviation
version.
or variance, replace xi with di. That's all. Shortcut method, when you just subtract
Trial version.
a constant number from each of the values of xi, then replace xi with di.
Trial version.
Step division method is that one where we use the variable ui, which is equal to xi minus a divided by c. That means we are dividing by the
Trial
class
version.
size. When we add or subtract certain value,
Trial
this is
version.
actually change of origin graphically. If we think of graphically, change of origin, shifting of origin. And when we divide or multiply by a certain
Trial
number,
version.
this is a change of scale. Now the standard deviation or variance, they are independent of the change
Trial
of
version.
origin or shifting of origin. But they do depend on the change of the scale. When we divide by C,
Trial
then at the
version.
end, to find out the standard deviation, we must multiply by C.
Trial version.
So this is the step division method that we used. We have already used the formula. What I was going to discuss is this
Trial version.
coefficient of correlation. Sorry, coefficient of variation. It is defined as
Trial version.
CV equal to sigma by x bar in 100. Standard deviation by mean into 100. What is it?
Trial
What
version.
is it about? What do you do with this statistical tool? What do we measure? When we compare two or more series
Trial version.
of data, if we use the statistical tool that is called coefficient of variation, when you are comparing the performance of two cricketers, again I'll give you the same example of cricketers.
Trial version.
When you're comparing their performances, who will you depend on? Who do you rely on? The one who is more consistent
Trial
on the
version.
field, who will give you certain runs always. or the one who may hit a century
Trial
or
version.
may duck it just to score a 0 or single digit. The first one is more reliable, whose scores are more
Trial
consistent.
version.
Yes, sir.
With this test, we can actually compare two series. The lesser the value of the coefficient of variation,
Trial
the more
version.
consistent the series is. So in terms of the player, the more consistent is the player. The series will be more consistent. It will be more clustered around the mean.
Trial version.
So when two or more series are given, we find out the coefficient of variation of each of them, and whichever has the least coefficient of variation,
Trial
that
version.
is the most reliable or the most consistent data. So that's all you have. I can
Trial
give you
version.
some example of coefficient of variation from the book. If I have any question, I'll give you.
Trial version.
Some more things were removed. We had combined mean, combined SD,
Trial
but all those
version.
things are not there anymore. Many things are removed. You are actually learning very little this year.
Trial version. Trial version. Trial version.
Not here.
Trial version. Trial version.
Okay, I'll give you some from the very beginning. All the types. First, this question. Very
Trial
common
version.
question. Where is it? Number 3. Calculate the
Trial
possible
version.
values of x if the standard deviation of the numbers 2, 3, 2x and 11 is 3.5. The answer will
Trial
be x
version.
equal to 3 or 7 upon 3. The standard deviation is given. You have to find out the unknown number 2x. Find the value of x.
Trial version.
Not 2x, find the value of x.
Trial
There was
version.
one more question. Find the standard deviation of the first 10 natural numbers like this, or the first n natural numbers. That I can't find out here.
Trial version. Trial version. Trial version. Trial version. Trial version.
Solve and tell me.
Trial version. Trial version. Trial version. Trial version.
Sigma xi, the sum of the values. 2 plus 3, 5 plus 11, 16, 16 plus 2x.
Trial version.
Like this.
Trial version.
Then you find sigma xi square.
Trial version. Trial version.
Now you do it.
Trial version. Trial version.
So 4x squared plus 64x plus 256.
Now get the answer. Substitute
Trial
the
version.
values with the formula and get the answer.
Trial version. 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 Trial version.
Given the standard deviation is 3.5.
Trial version.
This implies
Trial version. 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 Trial version.
If you can follow, then just put in the values. Sigma
Trial version.
xi squared is 134 plus 4. N is 4. Sigma xi is 11 plus 3, 16 plus
Trial
2x. Sigma xi whole square, that is 16 plus 2x by 4 whole square. This is equal to
Trial version.
7. Let's solve this now and tell me
Trial version.
tell me whether it values. It should be 3 or 7 upon 3.
Trial version. Trial version.
Just solve this equation.
So the RHS is 7 by 2 whole square.
7 by 2, I'm sorry. 7 by 2 whole square. What is all this?
Trial version.
It's
Trial version.
solve and tell me if you are getting the answer or not.
Trial version. Trial version.
If yes, then
Trial
I'll move
version.
on to the next one.
Trial version. 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 Trial version.
So I hope this is done.
Trial version.
Understood this?
Trial version. 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 Trial version.
Solve and tell me the steps.
Trial version. Trial version.
Calculating the mean and variance of 10 readings, the
Trial
student
version.
wrongly uses the data 52 or the correct data 25. He obtained the mean and variance as 45 and 16 respectively. Then find the correct mean
Trial
and the
version.
variance. How do we proceed?
Trial version. Trial version.
This is from ML Agarwal.
Trial version.
But tell me the result.
Trial version. Trial version. Trial version. Trial version. Trial version. Trial version.
Even n equal to 10. What else?
So please wait.
Trial version. 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 Trial version.
So it's 43.81.
Trial version.
Just a minute. I think you're right.
Trial version.
Yes, variance 43.8.
Yes.
And
Trial version.
correct mean?
42.3.
Correct. Now tell me the values, steps. Both correct.
So
Incorrect.
summation of
Tell me.
Trial
the summation
version.
of x is 450. I mean the incorrect one.
450. Yes.
And correct one is 450 minus 52 plus 25.
Just a
Which
minute.
is
Trial
420.
version. Trial version. Trial version. Trial version.
From 450,
Trial version.
we subtract the wrong value. Wrong value was 52. 52.
Trial version.
And add the correct value 25, which is equal to 450 minus 52 plus 25.
Trial
That is
version.
at 423.
Yes, sir.
Then
Trial version.
incorrect variance.
Trial version. Trial version.
Incorrect variance is 16.
Trial version.
It implies
Trial version. 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 Trial version.
So, yes, the
Trial
summation of
version.
x squared is 20410.
First of all, you have to find out the value of incorrect sigma x
Trial
square,
version.
then correct sigma x square, and find out the correct variance. That is a step. So when you
Trial version.
when you substitute the values to find out the incorrect value of sigma x square, which value do we use here for sigma xi by n whole square?
Trial
Which value do
version.
we use?
Incorrect value.
Incorrect value, correct. That is correct. Incorrect value is correct. So
Trial
incorrect.
version.
Incorrect this
Trial version.
minus incorrect mean 45. So 45 square.
Trial version. Trial version.
Incorrect variance, that should be, yes, that is 16.
Trial version. 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 Trial version.
So what is the incorrect value of sigma xi square?
So
Trial
20410.
20410.
Then you have to find the true value using
Trial version.
20410 minus 52 square plus 25 square.
Correct sigma xi square.
Trial version. Trial version. Trial version.
Correction. 20410. Find out of the wrong plus square of the correct.
Trial version.
Wrong value was 52 square.
Trial version.
Plus square of the correct
Trial
value.
version. Trial version.
Is it like this?
5331.
Trial version. Trial version.
Correct variance. So you find the correct mean.
Trial version.
So now we'll use the correct mean and correct.
Correct mean and
excess.
correct variance. Yes.
Yes, sir.
Trial version.
Correct mean. This is the correct sigma xi. 423.
Trial version.
Yes, sir.
This is equal to
Trial version.
423 by 10. 2.3.
Trial version.
And
Trial version.
correct variance.
Trial version.
I'm not writing the formula again. Sigma xi square by
Trial
10.
version.
Sigma xi, correct sigma xi square.
Trial
18331
version.
by 10 minus correct mean
Trial
whole
version.
square. Square of corrected mean 42.3
Trial version.
whole square. And this value is
Trial version.
once again
53.8.
40. When it's done, if there is any doubt in the sum, it's a good one.
Trial
And the teachers
version.
also like this sum. I know it. If there is any doubt, tell me.
Trial version. Trial version.
Time didn't permit, I couldn't show you the application of coefficient of variation, but in the exercise following the
Trial
standard deviation,
version.
there's one more exercise on coefficient of variation, and you will find sums like two data given, two series given, and you have to find out which
Trial
one is more
version.
consistent. So there, you have to find out the
Lower
coefficient of
value.
variation. Yes,
Lower the value, more the consistency.
lower the
Trial
value of
version.
CV, the coefficient of variation, higher is the
Yes.
consistency. Just keep that in mind. In both the series, you have to find the mean
Trial
of
version.
series 1, mean of series 2, standard deviation of series 1, standard deviation of series 2, and then find out the coefficient of variation of series 1, coefficient of variation of series 2.
Trial version.
Whichever series has the less coefficient of variation, that variable is more consistent. So there are applications like this.
Trial version.
That's all you have in the statistics. If you find any other type of sum, but I don't think there's anything other than
Trial
these.
version.
We discussed all the types, beginning with mean deviation about the mean. Oh, we haven't done anything on range. In which you have
Trial
to
version.
look at the values given, find out the smallest value and the largest value, The range is largest value minus smallest value. That's all. Just one line answer.
Trial version.
Find out the largest value, find out the smallest value. Subtract, you get the range. So range is done. Mean deviation about the mean. That is done.
Trial version.
Of all the type without frequency, simple frequency distribution, grouped frequency distribution, standard deviation,
Trial version.
again 3 types, and coefficient of variation. That's all. There's nothing more to it.
Trial
And now
version.
let us decide what we do next week. What is left now?
Conic section.
Conic section, section B, correct.
That's
So we'll
right.
start
Trial
section
version.
B, conic sections. Is there any one of you who is not doing section B? In that case, I have to,
I am not doing section B, sir.
we are not doing.
Trial version.
For those who are not doing section B, simultaneously, I'll be giving you a revision of sums.
Trial version.
So we'll do parallelly. When we'll do this, we'll do the revision parallelly.
Okay, sir.
Trial
We'll
version.
revise section. What about correlation? Has it been removed?
Trial
I'm
version.
not sure. Is correlation removed from syllabus?
I don't know. We have not started section C
Trial
yet.
version.
I'm checking on.
Because we haven't done correlation. I'm not sure whether
Trial
we have
version.
correlation in the reduced syllabus. Just check it once and tell me. Yes.
Trial version.
Again, Badrij, I can't hear you.
Checking.
Trial version. Trial version.
Doing section C,
Trial
second B.
version.
Voice is cracking. Can't hear you clearly. Voice cracking.
Trial version.
Second B.
Please send me a message. Can't hear you.
Trial version.
So we have decided we'll do section B and parallelly a division. Either section A or section C.
Trial version.
I would prefer section A. Revision on section A.
Trial version.
Sir, it is there in the reduced syllabus.
It
Yes,
is
the
there.
correlation is there.
Trial version.
Then you haven't done it. Then you have to do the correlation.
Yes,
What
sir,
I can do,
have
I can give you the theory of correlation with some
Trial
model
version.
answers. Seeing that you can do correlation parallelly, simultaneously.
Trial
And
version.
if you interact with me, yes. Was it so you?
It is there in the syllabus.
Here it is there. Yes.
Trial version.
So we'll do both. I'll give you the correlation sums,
Trial
model
version.
answers, theory and model answers, and we'll do parallelly. Conics and correlation parallelly. I don't think you'll have any doubt
Trial
after
version.
seeing the sums, solved examples. Okay. So we end the session. If you have any other question, you may ask me now.
Trial version.
So I hope you don't have any other question. Then good night, everybody.
Trial version.
See you next week.
Good night, sir.
Thank you, sir.
Trial version.